Hello guys, I hope you are all okay. It's me, it's Bongi. Anyway, today this is lesson number 5, if I'm not mistaken. And what do we have today? Today we have the MOSFETs, and I would like to make this clear again. This book is not my book at all, but it's a book from the guys I mentioned. Sorry, I mentioned earlier. You will see their name. Rem Infotech. Those are the guys who did the book, or the guy who did the book. I don't know anyway. But let me tell you something. Today, let's learn about what? Let's learn about the MOSFETs. Okay, there are two types of MOSFETs. We have the N channel MOSFETs, and we have what? We have a P channel MOSFET. Alright. Why the two? Why do we have the two channel MOSFETs? Let's make an example. Let me show you something. Let's go into my hard drive. I'm going to my hard drive. I don't know why my PC. Something is wrong with my Windows 11. Okay, let's go again for repairs. I'm gonna open a schematic here. I wanna show you something. PDF. Say Lenovo. We can take any brand. Okay. All right. Let's open this. We have the schematic, right? I want you to see this. I want to explain why we have two types of MOSFETs. Why I want to explain this. Why I want to show you this. Why we have two types of MOSFETs, and I'm sure after seeing this, you'll totally understand the entire thing. Okay. Here we have what? A DC inject, right? This is the main 19 volts where it starts, right? It starts from here, guys. This is alpha and omega 4407AL. This is what? This is the P channel MOSFET. Alright. And the second MOSFET is the same thing. It's AO, which is alpha and omega. That's the manufacturer. The people who designed those MOSFETs. And 4455. The last digit 5. It's an odd number. Odd number, it means what? It means this is a P channel MOSFETs. Okay. Remember the function of these two MOSFETs here. What is the function of these two MOSFETs here? The function of these two MOSFETs here, PQ301 and PQ302, is to allow the power, the 19 volts, to pass by. If all the conditions are met on the laptop, then the 19 volts will be passed by, and the machine will work. That's all. They don't switch. They're not a switch, unlike the other ones. Okay, they don't switch at all. They're just there as switches to allow power to pass or not, and that's all. That's all. No other function. They don't turn on and off all those stupid things. No, that's just stable. Just like on and done. Imagine. All right, check here why I'm telling you this. Let's go back. Check this part. Here we have an N channel MOSFET, and one more thing I like, they specify here saying currently high. What does that mean? It means the N channel MOSFETs are capable of giving you what? A high current. Why will you need a high current? It's because the CPU needs high current, the motherboard needs high current, all those things, you understand? So it means for CPU, you can use a P channel MOSFET. Why not? Because we're being told here that a P channel MOSFET is what? Currently low. So we can use P channel MOSFET on a switching what? On a switching MOSFET. Meaning when you want to replace those two MOSFETs, switching for 3.3 or switching for 5 volts, you can't use a P channel MOSFET. Because why? It's got a what? A current low. It's got a low current. It's capable of generating what? A low current. For example, on a charging port, I don't see a reason why you'll want to put an N channel MOSFET. For what reason? Because we don't need any M's. There will be nothing is turning on and off, nothing is switching here. There's no PWM here. Even if you put one MOSFET, it's fine. We don't need all those switching MOSFETs here. The ones we have here, they only turn on and off when needed. That's all, and they only turn off when there's a fault on the motherboard. That's all. So that's why when you are checking this, when you are repairing the motherboard, you notice that the first and the second MOSFET are always the P channel MOSFET. But I've seen some cases where there are N channel MOSFET. Not saying it's always the case, but in most cases, they're like this. Okay, this thing, guys, it will make sense to you. Okay, this will make sense to you. Let's continue. If G is high, the voltage in D should transfer to what? To S. Okay, what that means? It means, remember, the MOSFET is being controlled where? On the gates. By what? By a controller, by a specific chip. Right? So it's being told or instructed where? On the gate. It's gonna be the fourth pin. That will be what? No, wait. Yeah, it's gonna be the gate, the fourth pin. When you check the MOSFET, yes, here. Even here you can see the fourth pin is gate. We have screen, we have source. So what are they saying about the N channel MOSFET? They're saying if G is high, the voltage in D should be transferred to S. And about P, if G is low, voltage should be transferred to D. So it's vice versa. Okay, if there's high voltage there, then the gates will be turned on, which means the chip will, the MOSFET will allow power to pass. But for the other one, it's just vice versa. Anyway, guys, don't let this thing stress you. This is so simple. See, what I've told you so far, it's exactly what you need to understand, and that's exactly what the book is telling you. I'm not sure if I do make any sense, but that's it. Let me continue. Remember, this is path width modulate. So this is where the MOSFETs turn on and off to generate a specific volt. For example, here we have 18 volts, but we need an output of how much? Of 5 volts. So how you gonna turn that 18 volts into a lower voltage? By switching it on and off to ground, on and off to ground, and you'll have the spark. After the spark, you'll have a coil, and the coil will push that output to a specific voltage, depending on how fast those MOSFETs turn on and on per second. Then we'll have that specific voltage. So it's gonna be, if you use an oscilloscope, you'll see that they are switching that thing on and off, like go back to 18 volts, back to 0, 18 volts, back to 0, 18 back to 0. You'll have like some sort of a graph when you check this thing under an oscilloscope. Okay, and again, here you don't want to put a P channel MOSFET. You have to put what? An N channel MOSFET, because not only that we want voltage, but we also want what? We want the current. Okay, because this is how it works. And one more thing I like here, they're showing you that there will be a PWM controller, a specific chip controlling those two MOSFETs, and you have U gates and L gates. U gates is mean upper gate, that the pin controlling the upper gate, the upper MOSFETs, and the L gate, the lower MOSFETs. Have been controlled by a specific chip to generate what? A specific voltage. In this case, they are taking 18 volts and they are turning it into a lower voltage, of which is 5 volts. Anyway, guys, I like these lessons. I just like them. If you fail to understand this from this point, then I'm telling you, you really have to do something about your mind. Anyway, I'm gonna stop right here. I love you so much. Keep watching, subscribe, and like my videos, and don't forget to share. Bye bye.